Well, hello and good morning, everybody. How you doing? This is Jeremiah. We are having yet another webinar in our technical series here. This is our famous little year-end hardware recommendations, just in time for you to get your little Christmas list in, tell Santa what you want. I got a couple housekeeping items for you before we get going. This is being recorded, so you'll be able to refer back to it because there's obviously going to be some technical specs. We're going to not necessarily read every single thing on the screen, but it'll be nice to go back and check the recording. And at the top of your screen, there's a little view options, little drop down thing. I like to get to that if I need to exit full screen mode to get to a very important thing on the monitor. But otherwise, you can keep it all full screen. But the Q&A button at the bottom of your screen would be very good to familiarize yourself with, because you could even click it right now and get ready to type in any questions so that we can get them answered, because I'm sure there's going to be lots of good technical questions on this. So that's all I have to say. So get ready, strap yourself in. Let me get this handed over to Bennett.
Thank you, Jer. So like Jeremiah said, another entry in our hardware recommendation series. Generally it's a pretty good idea to follow up on these. New hardware comes out, old stuff gets retired, and system requirements, of course, change throughout the years. So let's go ahead and dive right in. This is me. Apparently I've been doing this for 10 years. I don't really keep track because time just disappears on you. I'm probably gonna have to just remove that from the next one. So let's take a quick look at what we're going to be going over this year. First things first, we're going to take a quick refresher course on what you actually need to run the LandFX plugin. Basically, what components you're going to have to be able to utilize the plugin properly. We'll also take a look at a technicality breakdown. Lots of acronyms in the tech world, lots of different phrases. So we'll take a look at a couple of the common ones that we'll see throughout this series. Hopefully make it a little bit easier to understand. The LandFX versus AutoCAD requirements is pretty self-explanatory. Basically, we'll see what AutoCAD themselves are recommending or required to run the software, and then what we kind of adjust for what we see makes the software run the best in all situations. The 3 B's: budgeting better for your business. You do rely on your computer for your business, so it's important to make sure that you account for that in your budget. PC or Mac, this comes up quite often, especially around here because we are an all Mac office, yet the plugin runs in Windows or on PCs. So we'll look at a couple of the pros and cons of both. And then the meat and potatoes of what everybody actually shows up for, what we actually recommend. A few key systems that we personally like within the office, or that meet a few criteria that really, say we should probably throw this on here. Networking is pretty crucial, especially when you're working with cloud-based software like the LandFX plugin is predominantly. All of our content libraries are cloud-based. So we'll take a look at wired versus wireless and see a couple of pros and cons for one or the other. Additional peripherals are going to be monitors, keyboard and mice, things that you'll use with your computer. And then, of course, we are bringing back the backups. Backups are crucial to your everyday routine because if your main machine goes down, what are you going to do? So we'll take a look at some best policies there. All right, so first things first, let's take a look at how or what you need to be able to run the LandFX plugin. So all in all, the LandFX plugin is made up of 3 core components. You have the folder, which contains blocks and locally created content like details. If you create or if you make any custom fonts with LandFX, if you modify any hatches, all of that is stored in the LandFX folder. You have our cloud-based content libraries containing thousands of blocks and symbols for you to use. Those are downloaded on demand, so they're not, you don't have this massive installation. You just have what you use. You also have a database. Now, the database is what contains the LandFX projects that you create, which houses the list of equipment and species of plants that you use in a file. It also includes your LandFX preferences and templates and all of the data that makes our smart blocks, well, smart. So how these components are going to run on your system, in order to run it, you're going to need three pieces. Again, we're sticking with threes. You'll have a workstation with CAD, either AutoCAD or FXCAD, and FX Workstation installed on it. You will have our cloud-based libraries and database rolled into one if you opt for our cloud data offering. And then you'll have an installation of FX Server, which houses the LandFX folder to hand out all your custom content to any workstations. That's the same setup if you're a single or multi-user. So let's take a brief look at a single user setup. So the simplest single user setup is going to be everything on one system. You've got CAD and FX Workstation installed on the workstation. Then you install FX Server on the workstation because you have to have that LandFX folder. And then you will utilize our cloud-based libraries and database. Now, the reason we keep talking about the cloud-based database is it keeps the minimum number of components on your local workstation for fewer points of failure, fewer maintenance points. It just makes it a little bit simpler and easier to set up. Now, if you're in a multi-user environment, that's a little bit different. So the simplest office setup is going to be, you'll have, as with the single user, you'll have CAD and FX Workstation on each of your workstations. And then we like using a shared online folder for the LandFX, for the FX Server installation. So you can use Google Drive, OneDrive, Dropbox, share a file. There's hundreds of these. You'll utilize that with our cloud data. So you don't have a physical tether to one location. You can have a user in California, you can have a user in Florida, you can have, people all across the globe accessing the same content. So that's why we like the shared online folder system, because it tends to make it tends to make sharing a little bit easier, and you don't have the additional overhead of needing to maintain a server. Now, if you didn't want to go the server route, you do also have the local data option. So you will also use workstations with CAD and FX Workstation set up on them. But instead of installing FX Server in a shared online folder, you actually load it up on a local server in your office. You will also use a local database. So when you're running multi-user, that's going to be MySQL. So that's an additional service and file that has to be running on the server and maintained. So one more thing to keep in mind if you're going to be running this all in-house is a few more components that you need to keep tabs on. Anytime you are on a workstation and you try to access a symbol or block or component that you haven't previously used, they automatically download that content from our cloud libraries and it's stored on the local server for future use. So you still have content sharing between all of your workstations, but they have to be connected to that local server. So, if you move off site, you will need some method of connection back to the server in order to use the software. Okay, technicality breakdown. You are going to hear a lot of acronyms throughout this video. We're going to talk about, measurements, gigabyte, megabyte, things like that, hertz, and all kinds of things that are going to be confusing. So let's try to break those down really quick. So the main things we're going to be talking about here are components first. So we're going to talk about a CPU or processor, which is a central processing unit. You can essentially consider this as the brain of the computer. It does all the thinking. RAM or memory is going to be random access memory, and it's essentially working space. So like if you were to unload a storage unit or you were trying to look for something in a storage unit, you would pull boxes out of the storage unit, put them on the ground in front of it, and sort through it to find what you need. That's essentially what RAM is. SSD or HDD or hard disk is a solid state drive or hard disk drive. That's your storage medium. And you can consider that the storage unit itself. So everything gets packed into the storage unit for permanent keeping. And anytime you have to do anything with it, it gets pulled out. Your GPU or video card is a graphics processing unit. And it's a specialized CPU or processor that accelerates output of your files to a display device. So anytime you open a file or do anything with that, the GPU is what handles moving that onto your screen. So for units of measure, gigahertz is a frequency. And that's generally what you're going to be talking about when you're talking about a CPU speed or a memory speed. Nowadays it's rated in gigahertz. A gigabyte is generally what you're going to be looking at when you're talking about your RAM capacity or your hard drive capacity. It's equal to 1024 megabytes. It's kind of hard to put that into perspective, but your average size PDF file is going to be 8 megabytes, and a gigabyte is going to be essentially 1,000 times that size. So you can fit a lot of 8 megabyte PDF files in a gigabyte. Terabyte is 1,024 gigabytes. So most hard drives these days are going to be rated in terabytes, either 1 terabyte. Generally, you'll see them up to about 4. The last one here is gigabit, not to be confused with gigabyte. Generally, this is going to be referred to when you're talking about networking. So like if you are paying for an internet connection that has a 20 megabyte download is what they'll tell you when you're signing up for it, or 20 megabit rather, you'll actually get 2 megabytes on average of a usable connection speed. It's about 8 times smaller than a gigabyte. So gigabit is going to be networking, essentially. Gigabyte is going to be storage capacity and storage size. So this is a very simplistic breakdown of essentially the workflow of a computer. So when you go to open a drawing, for instance, the CPU has to locate those files on the actual SSD or hard drive. Once it finds those files on the SSD, it moves them into RAM. RAM is generally about 50 times faster than any SSD or hard drive that's on the market. So working out of RAM is much, much faster. Once it's moved into RAM, it needs to be displayed on your screen. So it now moves those files into the GPU's memory. And then the GPU takes it from there and outputs it to your display. This happens every time you open a file. And until you close that file, it's still in your GPU's memory. So this is one way that your GPU memory can get eaten up, especially if you run multiple displays. Because even if you're not doing anything on the secondary display, it still has to load, your background and your icons and everything. So, like for instance, here in the office, we have some users who have 2 displays, 3 displays, and because they're high resolution displays, a lot of the GPU's memory can be eaten up just by running the desktop. So that's something to consider as well. A quick breakdown here on hard disk drives versus solid state drives. So on the left here, you'll see essentially what makes up a hard disk drive. You have platters, which are what actually store the data on, and those are spinning, depending on the hard drive, at 5,400, 7,200, or 10,000 RPM. The read-write head is what actually moves across the platters and obviously reads and writes the data to them. You have the spindle, the actuator arm, actuator axis, and the actuator. So all in all, with a regular hard disk drive, you have 6 moving points of failure. That's important to note, moving, because especially if you're on a laptop and your laptop drops while your computer is on, that sudden move and impact can damage any one of those moving components, and it could render the drive completely useless. The average boot speed for a hard disk drive running Windows 10 these days is going to be anywhere from 40 seconds to 1+ minutes. And 1+ meaning, if you're on a 5,400 RPM drive that's been in use for a year or 2 years and it's getting hammered on, you might sit there it might be time to go make a cup of coffee if you have to reboot your system. Moving over to a solid state drive, you basically have 3 components. You have the cache, which is where files are moved temporarily when writing to the drive before it's moved into the flash memory. And then you have the controller, which basically handles all of that. It's essentially another processor that's dedicated to the drive itself. So you have 3 fixed points of failure, and fixed meaning that solid state drives are far less susceptible to shock or impact damage With no moving parts, you also have less heat generated, and it's smaller and much lighter. So you end up, we're going to keep circling back to laptops, but if you're in a laptop, you end up with a much lighter computer. Boot speed and applications with a solid state drive can see anywhere from a 2 to 400% improvement. So you'll take that 40-second to 1+ minute boot time down to 10 to 20 seconds. So that, consider the fact that if you on average have to reboot your computer, once a day for updates or once a week for updates, and you're going to be using this computer for 2 years, 3 years, that minute per week is going to add up pretty quick. And I mean, like, I shut my computer down every night, so that minute per day definitely adds up real fast. So here's a quick overview of some effects of having an inadequately spec'd graphics card. This happens fairly often, but basically when you're zoomed way out in model space, as an example, you have very low visibility on, excuse me, very low visibility on small content. So you have low GPU memory usage. There's not a high level of detail. As you zoom in further, all of these smaller objects take up more pixels on the screen. They become more detailed. So your GPU memory usage goes up. A few things that you might see happen on the right here, if your GPU is low on memory and you zoom in, you may have labels that get blanked out, as you see there, because there's just not enough memory for it to load all that content. That's an AutoCAD effect. It basically decides what it's going to process as high priority and what's not. You may also see your screen flash when you try to pan around your model or paper space, and that's an effect from hardware acceleration. So if you have an inadequately spec GPU or you have a driver that is not compatible with that edition of AutoCAD, your screen may flash when you try to pan around in model space. All right, land effects versus AutoCAD system requirements. Pretty straightforward, pretty self-explanatory. Let's just take a quick look. So for AutoCAD 2020, I know there's a lot of numbers here. Just bear with me, we'll kind of go through them pretty quick. For the processor or CPU, they recommend a 2.5 to 2.9 gigahertz minimum. Generally a 3+ recommended, and the reason for that is AutoCAD is single-threaded. What that means is you may have a 4, 6, or 8 core processor. AutoCAD is generally going to use one of those cores. So the faster speed, the better AutoCAD is going to respond. For memory or RAM, 8 GB minimum, 16 GB recommended. 8 GB is pretty much the standard these days. You'll be hard pressed to find a laptop new on the shelves that does not come with 8 GB out of the box. A 16 GB upgrade for most machines is going to be anywhere from a $50 to $100 upgrade. Definitely worth it because, again, remember, you're not just using CAD at any time. You have your operating system running in the background. Maybe you're running Spotify. You have all these different things going on that are all going to use up memory. Now, display resolution. This is coming up more often these days. 1080p, or what has been considered the standard for a long time, that's the minimum, and 4K is now the recommended. 4K has been around for a few years now. It's not super new onto the scene, but a lot of firms are still adopting it. It basically has 4 times the number of pixels as 1080p, and that means you have 4 times or potentially 4 times the definition available. Now, that also coincides with your graphics card memory, of course, because you have 4 times the pixels, you're going to need more memory. That brings us over to video card RAM. 1 GB has been the standard for minimum, 4 GB recommended. If you're going to stick with 1080p, you can probably squeeze by with a 1 gig card. If you're even considering the possibility that you might want to take a look at 4K within the lifespan of the machine you're considering purchasing, absolutely you need a card with at least 4 gigs. No ifs, ands, or buts, especially if you're going to be running multiple monitors. A video card memory bandwidth, this is only on here because Autodesk has it on their system requirements. If you have a card that's been released within the last 4 years and it's not the bottom of the barrel, it's a $25 card that you can get on eBay or Amazon, generally it's going to meet those requirements. Disk space, 6 gigs. That's for the AutoCAD installation itself, not taking into account drawings or any files you're going to be working on. So I would take that with a grain of salt. It's basically just what the application needs to install with. For the LandFX system requirements, solid state drive. We no longer consider this optional. The improvement in just system performance, opening files, if you're working on multiple files throughout the day and you're going to be opening and closing CAD or working in multiple applications or moving from place to place where you may be shutting down or booting up your machine frequently, solid state drive is a huge time saver. And they also consume less power. So if you're going to be mobile, your battery on your laptop is going to last longer. We also slightly bumped the video card recommendations. Like I said, the 1 gig that Autodesk recommends might squeeze you by on a 1080p display if you're running a single display. So we bumped that up to 2 gigs to account for most people will run 2 monitors at some point, or they'll run a slightly higher resolution. So 2 gigabyte minimum, 4 gigabyte recommended. Other than that, the rest of the specs are pretty similar. All right, the 3 Bs, budgeting better for your business. This is pretty critical. I mean, you do rely on your computers for work, so it's important to make sure that they are up and running, or at least that you're accounting for the possibility that they may not always be up and running, because downtime is your worst enemy, essentially. So if you can be prepared to minimize your downtime when the worst case scenario happens, you'll be much better off. All right, we're going to start right off with downtime. So consider the cost of being down for 2 to 3 days while you wait for replacement parts to come in, or you try to wait for a shop to figure out a problem, versus upgrading your machine every couple of years. If you rely on technology for your daily routine, you need to maintain it just like you maintain your car. Especially if you're working with Windows, it's important to make sure you clean up temporary files, virus scans, system checkups, just like you would take your vehicle in and pay them to say, okay, go through it, tell me what needs to be replaced, tell me what's breaking. You don't want to run off the side of the road, just like you don't want your computer to just stop on you on a Friday when you have a deadline due in 2 hours. Internally here, we rotate out hardware every 3 years. That coincides with the warranty period. So we basically have warranties on our machines that last for 3 years. So when that goes up, we rotate those systems out for new systems with new warranties. So to consider how much you should actually budget for, first you have to determine the life cycle of your products. If you have a 3-year warranty, you have a 3-year life cycle. You could really push it to 4 to 5 years if you budget for out of warranty repairs, but that's not really something we find as best practice. The simplest way to budget for this is to take the full cost of your replacement and divide it by the number of years. So if you have a $2,000 system that you're going to replace every 3 years, set aside $670 a year, or about $55 a month. It's pretty negligible when it gives you the ability at the end of your warranty period to just say, okay, here's a new system. Order it. It's here in a day, 2 days, whatever. If you're going to push that life cycle to 4 to 5 years, your out of warranty costs can really be all over the board. You need to account for labor, parts, and most importantly, downtime. Your average technician cost these days is going to range anywhere from $65 to $120 an hour. That's for PCs. If you're working with Macs, the Genius Bar cost is $90 per half hour. It's up there. Fortunately, because they only work with Macs, the diagnostic time and repair time is usually a little bit shorter. As a quick example of parts cost, a replacement motherboard for a Dell XPS 15-inch laptop can range from $300 to $600. And that depends on the specs, GPU model, all that good jazz, because they are combined onto one thing. And then the most important part is how much is it going to cost you to not be able to work for 2 to 3 days while you wait for your machine to be repaired? A couple quick, easy ways to save because let's be honest, most of us are pretty bad about saving money, especially when your daily routine is super slammed. So the simplest thing to do is set up an automatic transfer out of your account. So once a month, you have it dump, that $55 a month into a separate savings account that you only use for system upgrades and repairs. A very easy example of one of these you can use, Capital One 360 savings accounts. These are high interest 1.9% savings accounts. They have no monthly fees, so they're completely free. You can have up to 25 different savings accounts under your name for completely different goals. So you can have one for your system upgrades and repairs. You can have one for your system technician that you pay. Go wild. Make as many of them as you need, but they're there for you to use, and they are a very useful. Um, they're a very useful component to keep in your pocket. Right up there, since we're talking about this $55 a month, hardware leasing is pretty popular these days. A lot of the big box manufacturers offer leasing options. A couple do note, Dell, Lenovo, and Apple all do. They offer various different packages, but for roughly the same $55 a month you'd put away for your upgrade every 2 years, you might be able to get away with just leasing a brand new system every 2 years for the same cost. So you don't have to worry about, well, what do I do with the old machine? Recycle it, find somebody to buy it, or throw it away if it just died on you. They vary from 12 to 36 months for your average one. I saw some that went up to 5 or 6 years. I wouldn't recommend those because, of course, you're going to be out of your warranty period at that point. So not only will you be making a monthly payment on the hardware, but if anything goes wrong, you're now also making a payment on repairs. So I would generally stick to the 2 to 3 year lease periods because that will keep you within your warranty period. So you're not actually paying out of pocket if anything goes wrong. Um, these are all going to offer either a fair market value or a $1 buyout option at the end of your lease. The fair market value is what we prefer. You're going to end up with a lower monthly payment. And then at the end of your lease, you have the option to either return the equipment and get a new system and continue your lease agreement. You can buy the system for what is decided as the current fair market value, which is going to be generally significantly less than it was new. Or you have the $1 buyout option, which is going to net you a higher monthly payment. But at the end of your lease, you basically give them $1 and you get to keep the system. Um, that's a good option if you're thinking about maybe giving the old system to maybe a family member as a gift or a friend at the end of it. But generally, at the end of these lease agreements, your warranty period is up. The system is 2 to 3 years old. So there's newer, better, faster technology out. So unless you're planning on maybe giving the system to somebody else or maybe helping out someone else with a newer computer if they're really can't afford a new system, the fair market value is the better option because you can just turn the system in at the end of the lease agreement and get a brand new computer and move on. All right, PCs or Macs? We generally get somebody asking this question maybe 2 to 3 times a month. They're in the market for a new computer, not sure which way to go. So let's take a look at a couple pros and cons. We're going to start with PCs or Windows machines. If you like to customize your gear, you can pick your own graphics card, your own GPU. You can swap out or use multiple hard drives. Generally, you're going to be in an enclosure that has space for a lot of the stuff. So I've seen computer cases that have space for 12 hard drives if that's your thing. You can upgrade components over time. So you may 2 years down the road from buying your machine, maybe your processor's still up to par, but your graphics card's looking a little aged. You can buy just a graphics card and swap that out, or pay somebody to do that with a desktop. Laptops, that's a no-go. They also offer touchscreen support. If you're into the whole tablet world and you like to be able to touch things on your screen to move things around. I know Brian here in the office is a huge touchscreen fan. Me personally, I've never really understood the use for a workstation machine. Obviously, for my phone, it's a touchscreen, but you have multiple platform choices. You're going to have laptops. You've got workhorse towers that are going to be silent operation. Basically, that's just a machine that's set up with multiple fans that are designed to be silent even when they're running full bore, so you won't even know the computer's on. You have tablets with detachable keyboards like the Microsoft Surface Book. That one's actually pretty cool. It's a full blown tablet by itself, and it also has a keyboard that attaches to it that has a graphics card built into it. So when you need a little bit more horsepower, you just pop that guy together and off you go. With PCs, you also can find a system to meet 99%, or you can 99% of the time you can find a system to meet your budget. That is a good thing and a bad thing. It's a blessing and a curse at the same time, and we'll talk about that in a minute. On the Mac side, maybe your PC options are overwhelming. There are tons of companies out there. With Mac, you have one manufacturer. You can go to one website and see everything that they have to offer. Your options are basically a laptop, a desktop, or an all-in-one. You're not going to be buying an iPad for CAD work. Well, for one, full-blown AutoCAD isn't on iPad yet, I don't think. But for your laptops, you have either a 13 or a 15-inch. Now, the 13-inch MacBook Pro does not have a discrete graphics card, so that one's pretty much nixed for CAD use. So you're basically looking at a 15-inch MacBook Pro. And if you're looking for a desktop, you're looking for a 21 or 27-inch all-in-one. Now, the new Mac Pro coming out, of course, does add to that list, but that system is much more expensive. Most people are not going to be going that route, at least not for AutoCAD use. With Mac, you do have that build quality. It's all of their machines are all aluminum construction. They are very well designed systems. They do fit and finish is very nice. You do have synchronization between your devices. So if you're a user who has an iPhone and an iPad and you buy a MacBook, you know, your notes and reminders and messages and all that jazz synchronize between all of your devices automatically. So that's convenient. And historically, they have fewer issues with viruses. It's not unheard of to get a virus or malware with Mac, but it's definitely much less common than with PCs. So a couple of quick cons here for Windows. We're going to circle back to that customization options. Tons of manufacturers. This can be good and bad. If you don't have, a few hours to sit down and go through and say, all right, I'm going to look for a system that meets all of these criteria. Well, you've got Dell, Lenovo, HP, MSI, Asus, Acer, the list just goes on and on and on. So hopefully you like numbers or you like researching things. Another thing to consider if you're going to do a custom build is each piece has to work with its neighboring component. It's very easy to throw a bunch of pieces in a cart or put a bunch of pieces together and then find out that you have the wrong motherboard or you have the wrong video card. I did that several years ago. I built a custom system that ran 2 video cards, and the motherboard I had only supported 2 video cards when running AMDs, not NVIDIAs. So got the whole thing together, fired it up, and had to end up tearing it apart to replace the motherboard. That was cool. Another thing to consider is major OS upgrades, like moving from Windows 8 to Windows 10, for instance, have generally costed about $100. I believe Windows 10 offered a very short period where you could upgrade for free, but once that period had passed, you do have to pay them money to go to the next version. You, of course, have the issue with viruses that are more common with Windows, so virus protection, malware protection, that's a mainstay with Windows. Like, it's something you just have to do. You have driver updates. Driver updates are basically software specifically geared for the hardware that tells it how to work with Windows or vice versa. So you have driver updates as well as software updates, and compatibility can be affected. So when maybe if you were to make that jump to Windows 10, but the drivers for your motherboard, for your Ethernet card or your video card hadn't been updated for Windows 10 yet, you may jump up to Windows 10, but now that hardware doesn't work because Windows 10 doesn't know how to talk to it. So that's something else to keep in mind. The system for any budget. It's great that you can find that 99% of people can find any system to meet their budget, but it's extremely easy to underspec. I could go down to Best Buy right now and I could buy a brand new laptop for $200. It's going to be a Chromebook. It'll work great for browsing the internet. It's not going to run CAD. That's just not going to happen. So it's extremely easy to buy a system that does not meet system requirements, but it does meet your budget. So that's something to keep in mind. And remember, when you are shopping around, that you definitely need to compare the computer you're looking at to the system requirements for what you're expected to use it for. A couple of cons for Macs. If you like to customize, you have very limited customizations. You basically get to pick display size and color. If you're looking at the MacBook Pro, you have silver or dark gray, 13-inch or 15-inch. And we already talked about the 13, not cutting it, so you've got silver or dark gray. You have small changes to processor spec and RAM capacity. Processor usually has one or two options, so not too confusing there. And RAM capacity, I think for the 15 starts at 16 gigabytes and tops out at 32. Storage expandability is basically non-existent. You cannot change out your SSD. It's a proprietary solid state drive with MacBooks, so what you buy the computer with is what you get. Like, there's no RAM upgrades on most machines anymore. There's no SSD upgrades. So make sure you spec the system appropriately for what you're going to be using it for when you purchase. Generally, you will have a higher than average entry cost. You are paying for that in the build quality most of the time. Many times, you're still going to need virtualization software like Parallels to run Windows within your Mac, because a lot of applications only run on Windows. So you're still going to be bringing in some of those Windows cons using a MacBook, but the benefit is, if you prefer the Mac OS, you get to still work in that for primary use aside from what you have to do in Windows. You have limited repair locations for Apple. They do like to keep very stringent requirements for basically anyone that tries to be an Apple repair center. Most of the time, you're going to be looking at Apple themselves. So if you're considering going with an Apple, double check and make sure you have a service center somewhere nearby that you can get to relatively easily. I mean, I have one 5 minutes down the street from my office, but it's an hour away from my house. So if anything happens with my computer at home, I'm going to lose easily 3 hours of my day going back and forth to the Apple Center to get something repaired. So definitely something to keep in mind. All right, a couple quick comparisons. I know there's a lot of content on the screen. We're not going to read everything, but this is basically to compare a MacBook or PCs to each other. So these two machines, we've got the MacBook Pro 15, comes in at $2,800 in this configuration, and the Razer Blade 15-inch, that's a Windows machine, that comes in at $33, and that's primarily because of the graphics card that was required to get a 4K display on this model. That graphics card, the GeForce 2080, is the second from the top of the line right now in the gaming industry. You have one more above it, so it's a pretty expensive unit. Both of these machines have the same processor, same RAM. The MacBook has a bigger SSD, but a lower resolution display. One of the big trade-offs you'll see here is the MacBook. Apple, in all their infinite wisdom, recently, or a few years ago, decided to move purely to Thunderbolt 3 ports. It's a good idea, I guess, because it's a very fast port. They have external graphics cards now that you can plug into these things, that basically you can have a laptop with a small graphics card, plug in an external one when you have to do something really work heavy, and now you've got this super powerful graphics card that goes over a single cable. The downside is you need adapters and dongles for everything else. The PC one, you've got your USB 3. It still has a Thunderbolt port, so you still have one port with that expandability, and then you've got your HDMI outputs and all that. Both machines offer extended warranties. Definitely recommend taking a look at extended warranties when you're purchasing a machine, because most computers come with a 1-year warranty out of the box. few more quick examples here. The Dell XPS 15 we talked about earlier. This guy comes in at about $1,900 in this configuration, which is pretty good for what you get for it. The MSI, we recommended an MSI last year, so I thought it appropriate to include one again this year. They do still have highly rated workstation machines. These two also have the same processor as the two we just looked at. The Dell has 16 gigs of RAM. The MSI has 32 gigs. So you get twice the memory with the MSI. The MSI also has a workstation graphics card. Now, the Quadro series are designed for CAD, SolidWorks. You know, they're a workstation machine. Basically, what that means is they have graphics that are tested by AutoCAD and certified or approved. Like they go through and say, yeah, this works with our software without issue. You're good to go. So that is a benefit to having a Quadro series graphics card. Another main difference here, the Dell has a 4K display. It has a touch panel as an option for another $50. The MSI only has a 1080p display. Not a big deal breaker because a lot of people are going to use laptops with external displays anyways. So you can run a 4K external. Ports are pretty similar. You know, they got USB 3. The Dell does have a Thunderbolt. The MSI does not. So that's one trade-off. The MSI does have an extended warranty available, but I couldn't find any pricing info. So that's something you may actually have to call them for. All right. The core component that everybody comes for, what we actually recommend, what we like, and what we think you'd be able to buy today and run the software without any issues. That Dell XPS 15 we just talked about. Yep, he made it. Like I said, it's an impressive value for the 1900 that it comes in at. Considering a comparable MacBook comes in at almost $1,000 more, it's not a bad deal. You have a 9th gen 6-core processor, great for multitasking. You have lots of customization options when you order it. 4K display, 1080p, touch panel. You know, take a look at the listing page on Dell's website, and you'll see what I'm talking about. They have on average 10-hour battery lives. So maybe you're not going to be around a wall outlet all day. That might not be a problem. They are pretty lightweight, coming in at about 4 pounds, depending on the config that you go with. They have that Thunderbolt 3 port for easy expansion, external GPUs, really fast external SSDs, you know, all that good jazz. They come with a 1-year standard warranty, but they have a 3-year extended available. The MSI we talked about, they are certified, ISV certification, and that's basically for workstation level, Autodesk, SolidWorks. So these companies come in and they say, this system is set up appropriately to be able to run our software without issue. So you do have that benefit going with an MSI setup. It's comparable price to the Dell. It's also military grade. Now I know this is going to go, a lot of people aren't going to care about this, but basically it means that it meets certain shock and impact and dust resistant qualifications that'll say it would be, it's a reliable system. You can look up the standard if you like to really see what it means. It does have that 1080p display, so keep that in mind. If you were looking for a 4K, you would basically have to use an external monitor to get that. This one does have a 3-year warranty over the 1 year that the Dell comes with, so that is a benefit there. Say you don't want a laptop and you want a desktop. Well, just like the XPS 15 laptop, Dell does offer XPS desktops. Carrying with Dell tradition, they are highly customizable, and these guys start at about $1,100, depending on the config you go with. This price tag, it was in this config that you see here, had the same 9th gen 6-core processor, 16 gigabytes of RAM, and a 6 gigabyte graphics card. Now, the 1660 Ti is about middle of the range right now, I think. So it would be good for probably 2 years, but much further than that, or if you're going to run 3 high-res displays, you may stress it a bit. They do have a Thunderbolt 3 expansion card available when ordering. They don't come with it standard. So if you're considering the possibility of using Thunderbolt devices in the future, that's something to keep in mind. Carrying the same 1-year, 4-year warranty options. MSI also has some, not super flashy desktops. This is a small form factor system, which I personally really enjoy. My computer at home is a small form factor PC, and it's about the size of a shoebox. And it has, a 12-core processor in it and a graphics card that will last me for the next 5 years. So small form factor is actually really cool, and it's making a pretty big dent in the scene right now. So this machine has a same 6-core processor we've been talking about, 16 gigs of RAM, the same chip the same GPU that XPS had, and it's small enough that you could even put it behind your monitor, so you never even have to look at it. You don't have this giant tower that you have to find a spot for under your desk. They have a 1-year standard warranty. Again, MSI does offer extended warranties, but I wasn't able to find any info on it. And of course, we have the MacBook Pro as a recommendation. It's what we use in-house. Same 6-core processor, all that good jazz. 4 Thunderbolt 3 ports. That's probably the most restricting thing with the new MacBooks, is that they have a single connection type. So I literally have a bag of adapters in my laptop bag that I carry around with me now, because, well, you never know what you're going to have to use. Yeah, key thing to keep in mind with the MacBooks, make sure you spec it well enough to run Windows as well, because you're essentially running another computer in your computer. So it is going to have to be spec'd up a bit. Now, if you didn't like any of the options we talked about today, unfortunately, there are too many manufacturers and models available for us to account for. I try to kind of cast a wide net to see what get good reviews, who has good customer support, easy warranty processes, and include them here. But you can always take our system requirements. They're here on the screen, and we'll include them as a keynote once the webinar gets posted on our website. And you can take these specs, call up any manufacturer that you like, give them these specifications, and ask them to help you find a system that meets them. And they'll be more than happy to, because they, of course, want your business. All right, networking is pretty crucial these days, especially when you're working with a software that is cloud-based like ours. So let's take a quick peek here at wired versus wireless and why one is better or worse than the other. A wired connection, starting off, yeah, you are tethered to a physical location, but you get 1 gigabit average connection speeds. Again, that's that gigabit, not gigabyte. So basically, you'll be able to transfer files at roughly 100 megabytes per second. So if you have 8 megabyte PDF files, you could technically transfer 10 of those in a second. 2, 5, and 10 gigabit speeds are available to your average consumer. It just means you have to have the right hardware for it. 2 and 5 are becoming more readily available these days. 10 is going to be like power user level. You have no interference generally if you're going direct Ethernet cable. It's more secure, meaning generally you're not going to have a man in the middle listening to your traffic, especially if you use something like a VPN. Now with wireless, you have no tether. It's very convenient because you can obviously move about your office and stay connected. The AC standard now supports a theoretical speed of 3.2 gigabits, and that's theoretical because in a test lab where your machine is a foot away from the router, yeah, you can probably get 3.2 gigabits. But let's be honest, in the real world, your router is probably in a closet or in your office, and you might not always be in your office. Interference for Wi-Fi can be caused by neighboring Wi-Fi signals. Most people, if you go up and click your little Wi-Fi icon right now, chances are you're going to see anywhere from 5 to 10 other wireless signals. Each one of those causes interference and slows down your connection. Radio waves, walls, and appliances. If you are not in the same room with your router, any wall that it has to go through, metal object, decreases your speed significantly. The best connection with wireless is point-to-point with nothing in between you, line of sight. That 3.2 gigabit theoretical speed that it has there, that's split between all connected devices, so something to keep in mind there. And wireless traffic can be snooped. You can have somebody listening into packets, and they can pull data out of your wireless transmissions. So for production work, you should always be hardwired. Additional peripherals are, things that you'll use with your computer: monitors, keyboard, mice, things like that. Let's take a quick peek. So we've been talking about 1080p versus 4K this entire time. Here's a quick roundup of some 4K monitors. We're not going to go through all the specs. This, of course, will be recorded so you can come back and look at it. Each of these models has the same resolution, comparable connection types, and they're all 27-inch monitors in, well, the last LG's not. It's a 32-inch, and it's significantly more expensive. But this is a quick idea of what you could be looking for when you're looking for a 4K monitor. 550 to 379 honestly is not bad at all. Now, these are some 1080p, 1440p monitors. Maybe you don't want to make the jump to 4K yet, which of course means you have, you need a bigger graphics card and all that good jazz. So you can still buy 1080p displays. The 1441 in the middle is a slightly higher resolution. It's like the midpoint between your 1080p and your 4K. These also all have comparable inputs. The two Dells also offer charging over USB-C. So if you have a USB-C laptop like the MacBook, for instance, or I think even the Dell XPS and the Razer would support it, but they will charge over a single connection. So you have one cable going from your laptop to your monitor, and that cable charges your laptop, sends the video to the monitor, and enables your USB ports that are on the monitor. So that's pretty cool. The two Dells also offer daisy chaining, so you can have a second display connected to the monitor, and the one connection from the laptop will feed both. So that's pretty neat. Ultra-wide monitors. These are kind of new to the scene. I personally have an ultra-wide at home, and I love it. Moving away from a 27-inch, I did not have room for two 27 inches currently, so this was a good in-between. Generally, you're going to be looking at these resolutions here, depending on the size. They offer multiple inputs, same as before. They still offer the charging over USB-C. The tricky thing with the ultrawides is a lot of them are going to be curved, and that curvature rating that you see there is basically indicating the depth or how severe the curve is. And the easy way to remember it is the lower curvature number, so a 19 versus a 38, means the 19 is going to be more curved. And it essentially means that it's designed for you to be seated no further than 1.9 meters away from the display to get the best viewing angle. The 34-inch on the left is obviously a 34. The 49s are essentially the same thing as running two 27-inch displays side by side. And all of these monitors offer picture in and picture by picture. And what that means is you can run two different inputs on the monitor and display both at the same time. So you could have, like, I don't know, an Apple TV plugged into the HDMI port and your computer plugged into the display port, and you can have the Apple TV playing in a little box on the corner. So that's kind of neat. This is MSI's new 5K offering. If you're in the market for a 5K display, your options are kind of limited. At the moment, there was the LG 5K, which has a single Thunderbolt 3 input, which is great if you have a Thunderbolt laptop. If you don't have a Thunderbolt laptop, you're kind of stuck. You can't use it. You can't use a Thunderbolt monitor without a Thunderbolt port. So the MSI kind of fills that gap. It has your standard inputs, HDMI, USB-C, and it has a 3-year warranty out of the box. And I think it's actually cheaper than the LG. So that's one to keep in mind. A couple quick mice and keyboards. These are what we use here in the office. The Logitech MX Master 2. It is Bluetooth and will use the little Logitech dongle, the dingle dangle. So it can be paired with 3 different devices at once, and you can cycle through them with a button on the bottom of the mouse. So that's kind of cool if you move between systems. The Logitech keyboard, pretty standard issue, Windows keyboard, backlit keys, doesn't break the bank. If you like to be a little bit more ergonomic, the Logitech MX vertical mouse is pretty neat. Same setup as the MX Master 2, and I believe it can last like 6 months on a single charge, or 4 months or something like that. And if the battery ever does go dead on the MX Master and the vertical, I think with 3 minutes of charging, it's good for like 20 hours or something. So that's pretty impressive. The Apple Magic Trackpad, a little expensive for what it is, but if you use an Apple machine, it's very convenient because it works with all of their multi-touch gestures. Oh boy, words are hard. So like 4-finger swipes to move between desktops, bring all apps onto display to see which ones you have hiding behind windows, all that cool jazz. bringing back backups. We talk about this every year. Backups are crucial, very important to your workflow because you always want to be prepared for the worst case scenario, and you never want to be taken by surprise, like especially if you've come on a Friday and you got a deadline and your computer's not turning on. 3-2-1 method. We've talked about this before. We find it still to be the most reasonable method for cost versus reliability. There's other methods out there, but this one will fit the bill for 90% of users. Basically means you have 3 data copies. You have the 1 copy in production, the one that you work off of, and 2 backups. The 2 stands for 2 different media types. First type will generally be disk, like an external hard drive. The second type can be cloud. That used to be tape and other mediums, but most users aren't going to have access to that, so cloud is easiest. The 1 stands for 1 offsite copy. This can be, on an external hard drive or in your car, home office, storage unit, mail it to a friend, whatever. Or it can be another cloud copy, as long as it's not on site wherever your production backup is and your production data is. Very important with your backups, test them at least once a year. You don't want to have this backup procedure in place thinking, you're good for any event, and then when it comes time to actually use it, find out that it hasn't been backing up some of your data, or the data that it is backing up is incomplete, or if you're doing a cloud backup, for instance, and you're backing up a few hundred gigs, depending on your connection speed, it might take you a day to download that backup. So simulate the worst possible scenario, complete data loss, keep track of the amount of time it takes to get back to an operational status, and calculate the cost of that situation. Based on that, make adjustments to your backup policy to compensate or correct for it. This is our support team. We're all here if you have any questions, Monday through Friday, 8 to 5. We are, of course, happy to answer any questions you have, or if you need any guidance on anything, definitely give us a ring. I'm sure I've talked to some of you before, and I'm sure I'll be talking to some of you in the future. That about wraps us up, unless Jeremiah has any questions.
I don't see any. I want to remind anyone, you guys are welcome to chime in with a quick question. I know we went over a lot. Remind you again, we did record this, so you'll be able to refer to it again. But I do not see any questions coming in, so I think, we'll wish everyone a happy weekend and all that, right?
Have a good one. All right, everyone. Thank you for joining us.